Hello, everyone. Welcome to the Data Center Fireside panel discussion. Our topic today is Achieving Zero Trust and Cyber Resiliency in Data Centers with Caliptra, DCSCM, and Platform Root of Trust. Today, our panelists are Stefano Righi, VP of Security and Board Member for AMI at UFI Forum and Linux Foundation Chips Alliance, Munir Ahmad, Computer Architect at Lattice Semiconductor and co-author of DCSCM Spec at the Open Compute Project. And I will be your moderator and also a panelist. I am Mamta Gupta, Senior Director Marketing at Lattice Semiconductor, leading data center telecommunications and security segments. Welcome, everyone. It is great to have you here for this fireside panel on zero trust and cyber resiliency in data centers. This is such an important topic as we continue to see the evolution of threats and the growing need for robust, scalable security solutions. So today, let's explore the technologies driving the future of data center security. Some of them that are being talked about are Caliptra, Platform Firmware Resiliency, or PFR, as we'll call it, and some more. And we have discussed in our prior conversations, and it's also talk in the industry, the whole concept of zero trust in data centers and about creating layers of security that work in harmony. So these technologies, it is hoped and expected that when combined, will provide attestation, resilience, and dynamic enforcement of capabilities that can scale. Data centers are getting bigger and bigger and more complex, so you need scalable, resilient technology. And then one thing that has stood out in my work with FPGA-based security solution is the importance of standardization. Especially when you have so many players, you have worldwide, establishments, and then you have to secure all of them. So it's not just about having secure components, but it is about having a total system level security that will work seamlessly across geographies, across various contributors, and a thoroughly heterogeneous environment. So let's start our discussion with those, some seeding ideas. So Munir, I know this jives very well with the work you have been leading at OCP, especially with the Data Center Security Control Module, or DCSCM. And then you have been working on some other groundbreaking initiatives with with OCP. So let's start with you. And how do you see these technologies coming together to form a cohesive security framework?
Thank you, and absolutely, Mamta. So, if you look at it, OCP, we have been focusing on creating open structures and open standards that enable seamless integration of these technologies. And if you look at the zero trust, that it starts with attestation, and it's actually verifying the integrity of every component before granting trust. So Caliptra provides the fundamental or foundational layer of the trust by measuring the critical system components such as firmwares and bootloaders and other things as well. And that is where standardization of the solution like Caliptra come in. So they provide a consistent way to establish trust at the hardware level, no matter who built the device. So that's the basis of the Caliptra. But what is equally important is the resilience, which is where technologies like PFR come into play. So PFR ensures that even if a component compromised, the system can recover to a known good state that we already defined as a good state or golden state, things like that. And then you have LTPI, which is a part of DCSCM architecture, which can act. So LTPI is basically is a hardware interface, but this can act as a connective tissue, securely transmitting these measurements and alerts across the system override to see if that is needed to be done. So frameworks like DCSCM are required because interoperability is very critical. We cannot achieve zero trust without ensuring that Every component, hardware, firmware, and software can communicate securely and reliably. So together, these technologies create a layered defense that is adaptable and scalable and interoperable.
That is absolutely right. And it is really that consistency that is required to build trust, not just in the hardware, but in the entire ecosystem. When every player, whether it is a chip manufacturer, a data center operator, or a security software provider, is working from the same standard, you eliminate a lot of the gaps that attackers are always looking for. It makes the entire system stronger and more reliable. Caliptra, which is spearheaded by Chips Alliance and was accepted by OCP security by the OCP security working group, addresses the need for a standardized open source root of trust of measurement. The overall security posture of the silicon devices depend on establishing a core root of trust and from there a chain of trust. The core root of trust and the chain of trust must attest to the integrity of the configuration of the system and of the mutable code that continues the chain of trust. Its role is to ensure that every component in the system can be verified for integrity, starting from the firmware, which is essential in building a secure system that aligns with zero trust principle. Traditional root of trust architecture were usually proprietary and instantiated in discrete or integrated forms in various types of different platform architecture. Therefore, establishing a consistent root of trust on different hardware configuration while maintaining the flexibility is truly a challenge that we need to overcome. So with OCP introducing the composable security architecture, we are really in front of a game changer, which require a uniform approach to security that is necessary in order to achieve the desired consistency in the platform security orchestration. It is only with mutual attestation processes that you can guarantee that the overall integrity of the entire platform, ensuring also the device identity. Device identity is a concept that cannot be overlooked any longer. Machine identity is integral to zero trust architecture as the identity of the users of the platform. In this scenario, an external root of trust becomes essential to the platform security, providing capability like data recovery that are essential for a holistic security solution.
Yeah, very well said, Stefano and Munir. And speaking of trust, one of the aspects of Caliptra, that I find most compelling is how it focuses on measurements. So again, to summarize, what is Caliptra? Caliptra is a root of trust of measurement that is standardized and by Chips Alliance and OCP, and it can be put in every system, every SoC, every component that goes on a system, and it could then collect the identity and does the measurement for the system or for that component, and the whole zero trust chain can start from there. So it focuses on measurements, and by hashing and signing critical components like firmware and boot configurations, it really creates a verifiable chain of trust. So that's what really excites me, that how these measurements are coming from a standardized root of trust and are feeding into policy enforcement, and suddenly you can have zero trust environment built up in very heterogeneous systems. And so And then how this works, and that also fascinates me, that Caliptra provides these secure measurements, but then there is a platform root of trust, often powered by an FPGA, that takes these measurements, verifies them, and then enforces the policies dynamically. So if there is an anomaly, the FPGA can isolate the affected components or revoke the privileges immediately. So it's a powerful real time response capability. So this this is coming together now as an open source, open community, but standardized zero trust architecture.
Yeah. You are perfectly right, Manta. And uh, um, you have to take all these responses that are present at system level. Um, so at AMI, we have seen the importance of this layered approach, and Caliptra set the stage to provide trusted measurement, but you also need something like Tectagon XFR, specifically on Lattice FPGA, that is our firmware resiliency solution to act on this measurement. For example, if Caliptra indicates an anomaly in the system, Tectagon will leverage the Lattice platform root of trust, FPGA-based FR, in order to immediately take action to isolate the affected component. How? Rolling back a secure firmware version, or even can work with BIOS and BMC to lock down the system, isolating faulty components in order to prevent further spread of the security issue that been created. This proactive and reactive combination is critical in order to maintain security in real time. And this really is what is providing us the foundation for cyber resilient data center.
So yes, so this is a very critical point, Mamta and Stefano. So the division between the roles of a Caliptra and a PGA-based root of trust is this is what makes the architecture so effective. So if you really want to distinguish these two, Caliptra focuses on providing the data, the measurement, and attestation, and while the FPGA actually works or acts as a data to enforce the policy and system level software, and like Tectagon ensures that all the critical components and they keep secured. All the critical components they like to keep all these things secured at the system level. So it is like having a highly specialized security team where everyone knows their role and they work together seamlessly in a fantastic way.
Absolutely, Munir. And let us also not forget the flexibility that the FPGA bring to the table. FPGA can adapt to different platform personalities, policies, or also to evolving security requirements. This means that you are not just future proofing your security, you are also making it scalable across different use cases, whatever if the hyperscaler data center, or if we are at the edge in a smaller deployment at the edge.
Yeah, and scalability is such a great point, Stefano, because when you have this proactive and reactive, combination, that's when you can take zero trust at scale. And this is such a key aspect because data centers, as I mentioned before, are becoming more distributed, complex, and you need a technology that will not only be very secure, but also scale as we build out our data center infrastructure. So while Caliptra measures and establishes trust at the component level, Lattice FPGA based PFR is verifying the measurements and creating the trust at the platform level. And then AMI's Tecticon XFR is creating the chain of trust all the way to the whole system by enforcing policies, leveraging the hardware root of trust in the Lattice FPGAs. So this kind of construction of chain of trust, it really requires very reliable and seamless communication channels, because those are the, as Munir said, connective tissue to really enable this. So Munir, this is where LTPI and communication channels like I2C play a very big role in enabling mutual attestation and ensuring that the measurements from Caliptra can efficiently reach the enforcement layer.
Yeah, absolutely. As a matter of fact, if you look at the DCSM architecture, and LTPI is part of it, and what LTPI is, as you said, is a connective tissue, but we can work in a DCSM architecture, we can provide a security layer of our LTPI to ensure that the measurements and attestation data from Caliptra and the platform root of trust or PROD FPGA and the system level orchestration by XFR, which is from AMI, are transmitted without any kind of interception or any kind of temperation within. If you look at the DCSM architecture offers LTPI. So we can have a DCSM architecture with security layered over LTPI that can ensure that the measurement and attestation data from Caliptra and the PROD FPGA and the system level orchestration done by XFR, which AMI provides, are transmitted without being intercepted or tampered with. So by standardizing this transport layer, it becomes easier to integrate the different components and maintain a seamless flow of trust across the architecture. This is what exactly the Stefano just described about the composable security architecture.
Yeah, and that integration is really what ties the entire system together. When you have Caliptra and the orchestration software that drive the enforcement and they are working in harmony, you are not just building a secure data center. You are really creating a system that can dynamically adapt and respond to threats in real time. This is the essence of zero trust.
Yes, and that adaptability and real-time response, they position this architecture as a game changer. So we have now looks like a very good architecture for zero trust. So let's dive deeper into another important aspect of attestation. So at its core, attestation is about verifying trustworthiness. And Caliptra does this through precise measurements. So I will take a moment to take us through a brief overview of attestation and measurements that we are talking about. A lot of our viewers might have the question, what is being attested or measured? How do you do attestation and when do you do attestation? So, just a little bit of a blurb, if you were. So, measurements can be taken at various stages of a device's life cycle, and those measurements could be firmware hashes to ensure that the firmware has not been tampered with, or they could be bootloader configurations to validate a secure boot process. They could be cryptographic keys or certificates to verify a secure identity, or they could be a runtime software integrity check so that you check so that no unauthorized code is running. So these could be various kinds of measurements that will establish trust not only on the hardware but also firmware, software, keys, certificates, everything. And then when do you take these measurements? So again, the measurements could be taken during boot. That is the most common thing, so that we verify that the device starts in a trusted state. And then the measurements are taken by a root of trust like Caliptra during a secure boot process, or they could be taken at runtime, which is a continuous or a periodic measurement that ensures ongoing integrity, especially with systems that have very long uptime. So you may want to have these regular, runtime measurements. Or during updates, that's another critical phase where the system opens up to receive an update, and then you got to establish trust all over again. So measurements could be revalidated, when a new firmware or configuration is applied. So that answers the when of the thing. Now, if I were to address the how do you take the measurement? So normally a root of trust for measurement like Caliptra would take these measurements by hashing critical components or comparing them to a known good baseline. And these hashes could be cryptographically signed to prevent tampering. And these measurements, they really form the foundation for the dynamic policy enforcement. End of my blurb, so I can get down off my soapbox. But this is one of the questions I always get when I'm doing any kind of solution presentation or solution brainstorm with our customers. So I just wanted to add this to our discussion. So now let's get back to our discussion. So Munir, we mentioned, LTPI being the connective tissue and DCSCM being a critical part of the whole, zero trust and composable architecture. So how does DCSCM enhance this process?
Thank you, Mamta. So DCSCM with security, which basically is a mutual attestation, and if we can layer this over LTPI, which is essentially as an SPDM, which is not a new concept. SPDM is basically security protocol data modeling, and this is what the critical component here. And then it ensures that these measurements are securely transmitted to the control plane or enforcement platforms like the Tectagon XFR that AMI provides. And we can think of this as the secure pipeline that connects the dots between the measurement, verification, and enforcement. So what is exciting is that how we are evolving the platform root of trust to support this runtime attestation. So we talked about so far the boot time attestation, but this is runtime attestation is something is also very important because runtime configuration can change a lot of things. So this runtime attestation actually provides the measurements, not only the boot, but they will be continuous and providing the real-time visibility into the system integrity. This level of insight is very critical for zero trust, where basically we are constantly validating rather than assuming that in the runtime it is okay, and since the boot time is okay.
Yeah, Munir. I completely agree. I think that the next step is, in effect, a continuous validation. Um, we will move beyond the point in time verification to a real time AI driven validation of the entire platform, hardware, firmware, runtime behavior, everything. The combination of Caliptra standardized measurement that is based on SPDM as a secure transport and the FPGA based enforcement of the findings of Caliptra will make this possible. We will also see, thanks to this open standard, more collaboration across the ecosystem. And this is absolutely necessary in order to address emerging threats in a faster way, because threat actors are not stopping in front of anything. And this is where the technology like Tectagon XFR and FPGA-based PFR really come to shine, because Caliptra provide the trusted data. SPDM makes sure that is transported securely. PFR enforces the necessary action that are based on all these information that are consolidated inside the platform of trust. It is the seamless integration that at the end enables the center respond dynamically to emerging threats.
Yeah, that actually sums it up very well. And now I'm looking ahead and I wonder, so when you bring up the continuous validation concept, I wonder what is next where are we seeing these technologies evolving? I see that AI and ML are becoming increasingly relevant in this space. And if we have the capability of analyzing the telemetry from attestation frameworks like Caliptra, AI could possibly detect patterns and anomalies that humans might miss, or, you know, forever uptime. So, Stefano, how do you see AI augmenting the broader zero trust ecosystem?
Great point. Great point. So let me start saying that resiliency is not only protecting boot, making a recover when necessary, or providing secure update, but also means runtime monitoring of system-wide controls that are present in the platform, because these could be exploited too. And we are already doing this today in the existing solution in a semi-static way with monitoring of various buses. And But here is exactly where AI can really augment these capabilities, because AI is a natural extension of what we are doing with attestation, with monitoring and having access to runtime telemetry, um, uh, being received in a secure way via LTPI and SPDM. AI can really analyze this data in real time and predict and prevent potential issues. It is not only about reacting to threats, it is also about learning from the data in order to uh, strengthen the system dynamically in runtime. Let me make an example. If AI, for example, implemented into the platform root of trust FPGA, detect a recurring pattern in telemetry that indicates a developing compromise, slow or whatever. It is pro, you can proactively signal at the system level through communication with BIOS and BMC that some and enact the enforcement that can be executed by XFR, can be executed by other software component communicating with it in order to take action before the system is fully impacted. Um, this create this active chain of trust that is not static any longer, but dynamically evolve in real time.
So thanks. Yeah. So this is exactly is the point. AI and ML, which is ML means machine learning, can also optimize the resource allocation, and it can ensure that the most critical systems receive the highest level of scrutiny. So, for example, AI could help prioritize which system need immediate firmware updates or more frequent attestation checks based on the risk profile that the system is designed for or user is looking for. So that's a very good fit for the AI model.
Yeah, so, keeping the evolving chain of trust, I really like that concept, the evolving, almost an alive chain of trust that is responding and evolving, and then prioritizing which systems get more scrutiny or more protection. That is truly a very valuable thing for AI to be doing for zero trust. So uh, it makes the zero trust continuous and adaptive. So very exciting to see how technologies like Caliptra, PFR, AIML could come together to create a future-proof security framework. And at Lattice, we are investing heavily into incorporating AI ML engines in our FPGAs for security and other functions. And I see this data center zero trust environment creation as another avenue for the synergistic solutions, especially when coupled with the MI's approach at the system level. So we are coming to the last portion of this panel session. So as a wrap up, let's talk about what is next. So Munir, OCP has been working on some exciting new initiatives around attestation and PQC. What do you see as the future for composable architecture, Caliptra 2.0? All of these things, we heard about them at the OCP. Why don't you summarize for our audience?
Sure. So the next steps are all about scalability and adaptability. That's what we are looking at in OCP. So for composable architecture, we are focusing on runtime attestation, and also we are focusing on enhanced telemetry capabilities to provide the real time that is visible and actionable insights. And this has to be done in the real time. And with Caliptra 2.0, there is another thing is coming into the play as a post-quantum cryptography, which is called in as a PQC. So PQC is being integrated to ensure that data center security remains robust in the quantum era, which is coming very soon. So with our Lattice FPGA, we're also demonstrating support for various NIST approved PQC algorithms. We can continue. We are also continuing to march in steps with the evolving security standards and regulation that we see coming in front of us. So the goal is to make these advancements easy and to adopt, and we also were trying to align them with open standards, obviously like DCSCM, so that everybody can adopt it, and also keep to agile platform root of trust FPGAs, which is one of the key advantage of it being using FPGAs. So this is the way the organization can deploy quantum safe architecture without overhauling their existing systems. That's what the biggest capability that FPGA has today, adaptation and robustness.
That's a fantastic vision, Munir. And speaking of PQC, the urgency to adopt these solutions is growing with regulations like CNSA 2.0. I'm saying data centers must start preparing now, as the quantum computing could render traditional cryptography obsolete. And CNSA 2.0 is putting very stringent timelines on servers and firmware signing and networking equipment. So I would urge our audience to take note. And Caliptra 2.0 and PQC enablement in FPGAs will make this transition seamless, because now you can integrate PQC into data center attestation and cryptographic frameworks. And this not only ensures that data centers can protect sensitive workloads, not just today, but as these algorithms evolve, they can make use of the crypto agility of FPGAs, and they can secure their system for a long time into the future. So it's not a system that goes out of date if an algorithm changes or a new threat emerges on the post quantum horizon. So FPGAs give you that crypto agility.
Yeah. Also at AMI, we are taking a very similar approach, Manta, and we are embedding PQC in all our solution, Tectagon, Technomix FR, Aptio, Megarec, all our solution, of all our dynamic firmware solution will be covering PQC, combining quantum resistant algorithm with AI-driven insight and real-time enforcement, create that security model that is ready for the challenges that are going to last in the future.
Exactly. And as we move into this next phase of security, all the focus will be on creating adaptable, intelligent systems that can handle emerging threats. So it's no longer about one and done. You do the security once and then it just stays the same and then it becomes obsolete. No, we need to have an intelligent, evolving security system that is resilient to future threats. So let's leave our audience with some key takeaways. I'll start with you, Stefano.
Okay, it's a pleasure. Zero trust and cyber resiliency is an ongoing traveling, it's an ongoing journey. And embracing this technology, we can build data centers that are not only secure but also future proof. AMI is committed to this paradigm, integrating all platform firmware into an holistic solution, um, into a dynamic solution supported by our 40 plus years of experience. Our motto, power, manage, and secure the worldwide digital connected infrastructure, supporting mission critical solution, is an attestation of what we are all about for our customers.
Yeah, and collaboration is the way forward by working together to develop open standards and share best practices. We can tackle emerging threats to create a stronger, more secure ecosystem for all the compute and data center ecosystem.
And from my side, prepare for PQC. Prepare with crypto agility into your systems, with reprogrammable components like root of trust FPGAs. The quantum era is closer than we think, and open solutions like Caliptra 2.0 are leading the way to prepare for it, to prepare for resiliency against the quantum threat. So, wrapping this panel session now, thank you, panelists. It is clear that the future of zero trust in data centers is one of collaboration, standardization, and of course, ongoing innovation. So, I'll leave our audience with a call to action. First, engage with these open standards like Caliptra and DCSCM. They are designed to make security more scalable and interoperable, and your input is very important to shape their evolution. Second, consider how FPGA based solutions can enhance your security architecture. They are flexible, they are crypto agile, and they have the performance that is needed for the changing requirements like PQC and to enforce platform level policies dynamically, which is very key in zero trust framework. And finally, think beyond compliance. Zero trust, cyber resilience is not just about meeting regulatory requirements. It's also about building a secure foundation for innovation and growth. It's an opportunity to rethink our security infrastructure and to make it resilient for future use. So thank you, Stefano and Munir, for sharing your expertise and your thoughts. And thank you to our audience for joining us. Together, we are shaping the future of secure and resilient data centers. Let's keep this dialogue going as we navigate the challenges and opportunities ahead. Have a great day.